Welcome to this week's Sell It to Your Granny online radio show. My name is Neil Staunton and this is my co-host
Karl Ussher.
Welcome, Karl.
Thank you. Hi everybody. Good.
So today's show we're going to be talking specifically about what is big data. We're going to sell it to a granny.
A real granny.
And
We've seen her documents.
And then we're going to debate it. So first of all, I'd like to introduce ourselves. Karl, would you like to introduce yourself?
Yeah, so as I said, my name's Karl Ussher. I look after technology partnerships in EMEA for Google.
What does EMEA mean?
Europe, Middle East and Africa, granny.
That's a large place.
It is a large place.
And I'm not
I spend
granny.
a lot of time on the plane. So I should also say any of my views are not the views of Google Incorporated. They're just my views.
Okay, very good. Thank you very much.
And you, Neil, who are you?
My name's Neil, as I told you. I work for a company called Pivigo. We are data scientists on demand. Think of us as the Uber of data science. And I'm the growth hacker, which basically means responsible for growing the business.
Sales.
Yes, sales. Basically, I sell.
Hacking
Stuff.
and growth sounds better though. You're
It
right.
does, doesn't it? It's a little bit more. It's less salesy, isn't it? Okay.
Have you ever hacked anything in your life?
Just some wood.
Touche.
Is touche appropriate?
Yeah.
Okay, very good. So today we're, like I said, we're gonna. It's called Sell It to Your Granny, and we are gonna take a technology question and make it so simple that even your granny will understand it. So before we get in, Karl, can you tell me if you've done anything interesting this week, or if you're doing anything interesting next week?
I've done a lot of interesting things this week. So many I can't even mention all of them. What's interesting is in a few hours I'm going to Singapore. That's going to be really cool to meet some of our tech partners over there and work on my suntan.
And you need a suntan?
Yeah, permatan. You got to keep this stuff replenished.
With the sun?
Yeah.
Okay, very good. Well, let's get going. So I'm going to give you 90 seconds to explain to the listeners what is big data. Go.
Big data is data that's big. Next question.
You've got 124 seconds left.
So effectively, we're producing data all the time. As an online user, you're constantly producing data. Let's take Google as an example. You go there, you search, you click on different links. Google's capturing all of that data. Now, the challenge is there's so many data points because we're looking at billions of people using these online services like Google every day. It's not easy to handle that data in traditional ways. So what is often used to define big data is the 3 V's. So it's the volume of data. So we're talking billions of data points every second. It's the velocity of data. It's coming really quickly. And it's the variety of data. So it's coming from different sources and different types, whether that's media, whether that's structured data or unstructured data. So handling all of this big data can help companies get better insight about their customers and understand correlations and better serve their customers. But in order to process that data, they can't use traditional methods. They need to be smarter about how they process all of this. And that's typically done in parallel. And you can have your 10 seconds back.
Okay, very good. Well done. Well, actually, I think that was a bit rubbish.
Yeah.
I think I can do much better.
You always think that. Delusional.
Okay. Delusions of grandeur. You've normally come back with me many times. Okay, here's my version. Big data, as Karl described it, is big. And basically why it's important and why it's important is the more critical question. And let me give you a few examples. Think of financial fraud. Before, we would only be able to store 2 years worth of data, and that means that because of cost reasons, but when you analyze data over 2 years, it may not pick out any trends or patterns. But if you then are able to analyze data over from 10 years, it's more obvious about the trends and patterns, and therefore you can identify when a fraudulent piece of activity, and we've all been a lot of us had our cards cloned. Let me give you another example. Amazon, because Amazon have millions of transactions of books and films and stuff that we buy, they're able to group us into kind of clusters of products that we all buy as common products, and therefore are able to recommend relevant products. And then there is hospitals where you can actually, the data from activity, I suppose the Google DeepMind example where you've got, I'm going to go over, but anyway, you got the Google DeepMind scenario where they're analysing 1 million eyes, and with that they're able to understand what are the trends and patterns in eye disease, and they're able to predict before these
you're
things.
over time. Your granny has left.
Well, she'd probably be interested, and therefore she would probably say it.
She's asleep already.
And okay, so that was my explanation. Any good?
Yeah, I think you hit on some interesting examples. You mentioned DeepMind. That's more artificial intelligence. But here's a question.
But you needed the data.
Here's a question. Could you understand fraud on small data? I guess you could.
You could understand fraud on small data, and it's more to do with engineering, machine learning, and engineering features to understand how what are more important critical factors in fraud, and you appropriate a weight to understand actually if this is more likely
too technical.
Okay, that was too technical.
So the thing is, you can identify fraud. What they typically do is anomaly detection. So if you look at large bulks of data and you don't look at individual data points, you look at when something doesn't match typical patterns. That's called an anomaly, and that flags up. Now you can look at lots of data in unison, and that's where the big data comes into, I guess. But also, you can do fraud detection on small data. You might know that certain transactions from certain locations geographically or using certain small patterns can be identified as fraud.
And the trick is actually, if you can find trends and patterns in small data sets, let's say over a smaller period of time, let's say 3 days, then it's easier to extrapolate over a longer period. So, but I also want to add something to your 3 V's. It's not 3 V's. It's actually 5 V's. Do you know what
it could be 6 V's?
No. Seriously, these are
veracity of data as well.
Yeah. So what's veracity of data?
The authenticity of the data.
The trustworthiness. Yes, very good. And then the 5th V.
Victory.
Actually, it's not far. It's value. So if it has no value to the world, there's no point even doing this, because you can find trends and patterns in lots of big data, but if no one cares about it, then what's the point? Okay, so I've got a few questions. Okay, why now? Why is it that big data has all of a sudden become big data? It's become a buzzword, and is it just a buzzword?
I think it's going through the hype cycle. It's probably at the tip of the hype cycle where everybody's talking about it. There's a funny slide I've seen, and it says, big data is like teenage sex. Everybody's talking about it, and nobody's really doing it right. And that's what teenagers do.
Is that you too?
It's been a while since I was a teenager.
A long while, I think.
Yeah, but that's basically it, right? It's really hyped right now. But I think big data has always been there. I think right now, there's some big internet companies that have, in the order of billions of customers, and they're producing one of those V's, a large volume of data at a high velocity.
Like Facebook,
like Google, like Yahoo. There's lots of these companies. So in order to handle that amount of data, they need to process it in a new way. I think another thing that's kind of driving this is the cloud. So now using cloud computing, you can start to handle and analyze this big data set. Whereas before, you would need really expensive mainframe computers in order to process that amount of data. So if you just take an example, let's say it takes a second to process a piece of data, right? So it's 1,000 pieces of data. You'd be done in 16 minutes and 14 seconds, right? Thereabouts, right?
Okay.
So that's easy to handle. If you have 1,000 customers, you can process that data. But when you look at the likes of Facebook and Google, you're talking about billions of data points every second. So let's say it takes you you have 1 billion pieces of data and you're still processing it at 1 piece of data per second.
Yeah.
1 billion pieces of data. How long would that take you to process? Let's say you had one machine and process it at 1
16
second.
million 16 minutes times 1,000.
No, take you 31 years. So that just puts in perspective the
What
volume of data. A billion, 1 piece of data, 1 second, billion pieces of data to process that would take you 31 years. It's incredible.
Okay.
So how do you handle that data then? What do you think?
Well, isn't one of the key things that's enabled this to happen is the cost of storage, the capability of storing the data, and the cost of storage is reduced.
Yeah, definitely, right. So with cloud computing, you can store this data in the cloud, and it's cost effective. You don't need to invest in buying the storage drives and the server resources in-house. You can store that in the cloud, so that definitely helps.
So what
about processing that
that's
data?
That's the processing, yeah. Go on.
So the data's storing it, but what about processing?
Well, I don't know enough. I think you can tell. I can give my version, which is with cloud computing, you can reach almost infinite number of servers and therefore power, and you can scale up. For example, I believe Google have 10 million servers across the world.
Where'd you get that number from?
The last time I Googled this.
Finger in the air. But I think you hit on some interesting points. I think it's the fact that, I wouldn't say infinite because infinite's a marketing term. There's definitely a finite number of servers, but you can access as many servers as you need on demand. So what happens is that processing that you would do on a single machine, you can now parallelize across multiple machines.
That's
so
very technical.
You work it in parallel. Parallelize is technical.
I'm glad you explained it for my granny.
Yeah. Granny, it's like when you do two things at the same time, you do them in parallel.
Okay.
Yeah. Surely you're 90 years, you'll learn that.
But my brain isn't working as hard. It's working as well anymore.
Yeah, so what happens is you can run these jobs not sequentially but in parallel, so they work together. And there was something invented by Google called MapReduce.
Okay.
You probably heard of Hadoop. Everybody talks about Hadoop.
Reducing maps?
No. It's the 2 stages within a process called MapReduce, which helps you handle this big data set. And this was invented by Google back in, I think it was the early 2000s. And
is it invented or was it just a white paper?
Well, the process was invented, and then
theoretically.
No, the process was invented theoretically and practically. It was used in order to process all these billions of web pages. How do you make copies of them? How do you analyze the highest rank? How do you rank 1 billion web pages? How do you do that? You can't do that on a single machine. That'll take you forever.
I'll count it with my fingers.
Exactly. So you'd still be there counting, and then the next day you've got completely new web pages that are launched. So it needs to happen at a fast pace. So the only way to do that is to do it on parallel computers, because Google wanted to do that on commodity machines, not to have just one single huge expensive,
which means that anyone
off the shelf servers. And the good thing about that is anybody can do it now, and that's what we're starting to see in enterprises, where large organizations are starting to be able to handle this big data using techniques that were developed by Google. So MapReduce, which is the precursor to Hadoop everybody's talking about, is this idea of you've like lots of machines. You take all the data and you distribute it across the different machines. You map it. That's the map part. And then every machine takes responsibility for the data, the cluster of data it gets. And what it does is it does some aggregation and summarization. And then there's a reduce step that looks across all the machines that have a table of contents, let's say, and then starts to aggregate the results together. So now you have all these machines working in parallel, and then you can get results from each of them and then bring them together in order to analyze all that data.
Okay, very good. And I kind of get it. And I hope other people listening will kind of get that. Okay. I think that was a technical explanation made quite simple. I think.
Thanks, mate. Let's ask your granny.
Be on the back. Well done. And also, so they went from MapReduce, and you say that was effectively the kind of the precursor to Hadoop. What is Hadoop?
Correct. So Hadoop is an evolution of MapReduce, again based on that white paper you mentioned. So it was, I can't recall the name of the guy, but I think it was a group of guys at Yahoo, maybe Facebook, that implemented it, turned into a practical. Yahoo, yeah. And he called it after his child's baby elephant. Yeah, because elephant is big.
Yeah.
And it had a cool and friendly name. MapReduce is a little bit technical, as you said, so he called it Hadoop. And then they started employing that technique that Google had invented with MapReduce at Yahoo to process all of the data and customer behavior.
Okay, so going back into like why now, it's because storage has become so much cheaper. It's easier to store more data. The processing is because cloud computing has allowed people to access all of or as many services as they want on demand, and basically being able to deliver results in super quick time. And then thirdly, it's how does that then connect to MapReduce and Hadoop, which is kind of decentralized computing?
Well, decentralized, I guess it's democratized computing because everybody can do it. It's typically centralized in a cloud. But you're right, so the barriers to access have fallen considerably.
Okay.
You don't need to purchase a mainframe computer in order to do this processing. You don't need to spend millions of dollars in computing projects to do it. You can use something like Google Cloud Platform, AWS, Azure. You can take your data and save it on their cloud and then process it using tools and techniques that they have. And you pay per minute. Well, at least with Google, you pay per minute.
Okay.
So you can have $100 and you can process your data on billions of users, which is incredible.
Could you stop plugging?
Stop plugging.
Google. They don't need any more plugging.
Yeah.
Okay, so more importantly, what's the everyday application? Why should people care? How is it changing our world for the better or for the worse?
Yeah, good question. I think for companies, they're realizing if we can better understand our users and their behaviors, we can better serve them. So we can provide more contextually relevant services to them because we understand their behavior better. And there's been some great examples where they've extracted key insights from data by bringing data sets together and processing them. So one good one is by Uber. They did a analysis in Seattle and San Francisco, and what they saw was there was a direct correlation or causation between the reduction in the number of DUI offences and the launch of their app.
DUI?
Driving under the influence, like drunk driving.
Oh, right.
So basically, as their app became more prevalent, the number of drunk driving cases went down. So
actually they're contributing to the world by eradicating the threat or risk of maybe kind of drunk driving deaths and stuff like that.
Well, with the data, they can prove that with the data at volume, and it tells a nice corporate story for them. I don't know whether that was their intention, but that was definitely a positive side effect.
So what do you feel about in terms of what's been in the news recently, or not so much in the news, but what actually has been released is Uber is now creating selfish cars. Very selfish. They won't let you in.
Yeah. They demand a tip.
Self-driving cars. So right now they've got 1 million people that are working for them or using the Uber kind of system, and what they've done well is that they've enabled anyone really to be to get a job in any location very easily. I think that's one great benefit of Uber, but if they're creating driverless cars, that means that 1 million people are going to be out of work, and those Uber drivers right now who thinking they're making money, what are they going to do when they find out that there's no jobs for them?
They're going to work as engineers and developers, creating the technology that runs in the self-driving car.
They're not capable.
Well,
they're not. That's not fair. They are capable, but currently they're not skilled and unlikely to go and get skilled to be engineers.
I think it's definitely a concern, right? Because the machines are coming to take our jobs, right? You see that in factory processing.
But that's just kind of more simpler tasks. Like driving is quite complex, but fundamentally it's just about viewing. It's just about awareness of space and speeds and kind of laws.
But there's so many variables that need to come into play. I don't think it's going to happen overnight. You know, the roads in Europe, in Ireland, in England, I don't know whether they'd support self-driving cars. In America, the roads are very large, they're very well marked, and in the cities where it's not, the self-driving cars get confused.
Well, until they stop getting confused, they won't be on those roads, right? They'll have to prove themselves.
Is this going to be a left driving or a right driving robot?
Is that why he's going to get confused, or she?
I don't know.
So, okay, so have you heard anything recent in the news about how kind of big data, in terms of using lots of data to create some sort of service, is going to be kind of good for the economy or harmful to people or anything like that? Anything recent?
I think there's lots of examples of companies leveraging big data. I think there's many examples of companies trying to leverage it and failing and not really knowing what they're doing. But I think looking at the data and not making assumptions, but looking at actual data sets can only be good. Netflix do a great job, right? So they capture billions of data points every day about when people start and stop and quit a TV show and which TV shows they like, etc. And they use that data to understand what people are interested in and create TV shows. So for instance, House of Cards was created using the data to say that people were interested in that type of show with a lead character like Kevin Spacey.
That's interesting. Just even more interesting is that the board member of my company, a lady called Lorraine.
You plug in your company, right?
No, she's the former BBC commissioner, commissions X Factor and other shows as well.
Was she there when Jimmy Savile was there?
I don't know. Anyway, moving on.
Good.
So I explained to her that big data and all these things enabled that show to happen. And she said, well, the fact is, Kevin Spacey's a big draw. That was a well-known show. The director was a very famous director. You put all these things together and naturally that's going to happen, which I think is a very valid point. But that's not the only use of big data for Netflix, is it? They use it for recommendations. They use it for user experience to make sure it's a seamless user experience.
People who like shows like this also like shows like that. So it is analysing all of that data. But the point that she made about it would have happened anyway. But, you know, if they're going to spend millions on a director and an actor and, you know, produce the show, they want to know it's based on data. It's not just a guess.
Yeah.
Because if they get that wrong, that's going to be an expensive error. But if they can base it on data, then it's more likely to get support, buy-in, and become a reality.
Because a lot of people make decisions based on gut instinct, experience, and so on. But now with big data, you can make that gut instinct, but it can be supported by data, and therefore you're going to be, if you want to know what the demand for that kind of content or show is, you can basically say, if we do this show, the data also supports that we'll have 10 million viewers a year, so therefore we need to make this show because it then becomes profitable because people want it.
So if you're going up and you're pitching for several million to run a show, and the executives say, okay, why? It's like, no, I just have a good feeling about it. Yeah, you're going to get laughed out of the boardroom. But if you have supporting data and evidence that they've captured using big data techniques, they're going to get that support.
Okay. So is there any way where big data is being used that's detrimental to society, and maybe like from a criminal perspective, anything like that you can think of?
The negative effects of big data, I don't know.
Do criminals use big data? Do hackers use big data? Do companies use big data to sell too much, to be like, because do we really need to consume more? They just want to sell us stuff because they're going to make them more profit. Like, I know cigarette companies and stuff like that. They just don't care about whether we die, really. Or actually, that might not be fair. It's more they don't care if we become unwell through smoking. They don't accept the harmful effects of smoking.
What's that got to do with big data?
Because I'm saying, do they use data to help target people in marketing campaigns?
There's probably a lot of companies that do very targeted, based on the big data, they target certain customers and maybe they ignored others. Maybe that's a detrimental effect. But I don't think it's anything too you're severe. I don't think it's malicious having better access to big data. I think the main thing it gives is insight that you can act upon. Data-driven decisions based on insight about your customers.
So how do you think it's going to change the world over the next 5 years? Is it going to change the world?
I think decisions will be made based on data, so people will make more informed decisions. I think that's happening anyway.
So some of the use cases that I really like are more on the kind of social space. So if you think about education, they're able to use data to personalize education. Because there's more insights and there's more behavioural analysis, understanding who the school pupils are, and then delivering them content and an education in a way that they will want to learn.
Yeah.
There's also I like the idea of actually being able to identify people who are at risk, kind of vulnerable children that are at risk of running away from home. And therefore being able to identify who they are and actually put in kind of preventative measures. So there are, I think, there's some really good things happening in the world by using data that are actually going to make a change to people's lives.
I completely agree. I don't know whether all of that is big data, but I think you're right. Having data analytics and insight is going to just be valuable. The more you can make data-driven decisions, the more knowledgeable and accurate you're going to be.
Okay. Have you got a favourite quote?
Big data is like teenage sex. All the teenagers are talking about it, but no one's actually doing it well.
I can't beat that. Thanks very much. So, if we're going to summarise this, and if we're going to call my mum, who is a granny, and we're going to explain to her what big data is.
We're going to call her a granny.
Well, we'll confirm that she is one. And then we will basically pitch it to her in a way that she now understands what big data is. Yeah?
Give it a shot.
We're going to do that. Okay.
Who's talking to her?
Me.
She's going to be like, Neil, stop talking to me about big data again.
well, now maybe I won't have to talk to her about big data again because she'll get it.
Maybe she'll be biased, be like, son, whatever you tell me, I understand.
Well, we'll find out in a minute, won't we?
Yeah.
Right. Okay. So we're calling. So my mum's in France at the moment.
Having wine and cheese.
Hello, Neil.
Hi, Mum.
Yeah.
You alright?
Yeah.
How are you?
Yeah, fine. You?
Yeah. How's your holiday?
Yeah, good. Not driving.
Okay. Oh yeah. By the way, this is an online radio show, so please don't swear.
Say that again.
This is an online radio show, so please don't swear.
No cussing.
Do I ever?
Good points.
Regularly.
Depends if I've been bad or not. Which is regular.
Neil, you're not very clear.
Okay, so Mum,
Yeah?
this show is called Sell It to Your Granny,
Yeah?
which is why you're on it.
Yeah, I understand that.
Okay, so just to confirm that you are a granny or a grandmother or grandma.
Say that again.
Are you a grandma?
Yeah, I'm a grandma.
Yeah, okay, good. So what we're going to do, we're going to explain to you what is big data.
Okay.
Okay. Do you know what big data is at the moment?
No, I
Okay.
don't.
So, big data is data that's very big. So why it's important is because, for example, if we're going to analyze data about bank fraud and kind of cloning cards and stuff like that, we need to be able to use lots and lots and lots of data. And
Yeah, okay.
okay, and what we need to do is we need to be able to store the data, and which basically it's come down in cost. We need to be able to process it using lots and lots of big computers, and therefore by the cost of entry to the market, it means that companies can actually use big data to prevent card fraud.
Okay.
Does that make sense?
Yeah, fine.
Karl, have you got a better version?
Ask your mum to play it back, or your granny.
Okay, Mum,
Yeah.
could you now tell me back what is big data?
Big data is gathering a lot of data so that the more you have, the lower the cost. And I think I might have missed the point there, that why it then became secure.
Well, why is it important?
Yes,
What
big companies would use it.
Why is it important to have lots of data? What does it give you by having lots of data on a customer or us?
Information.
Yes.
Better insight. I think we have a winner.
I think we've done well. Thanks, Mum.
And then that's it. I got the answer from Dad.
Well done.
Well done. See you then.
Okay, bye.
Bye.
I thought she was going to go, oh, it's got to do with card fraud.
Well, I think that was kind of that was a very exploratory, risky.
I'm really impressed at how your mum understood from your explanation.
Yeah, because your face was looking like that was the worst explanation ever.
She's obviously really smart. Pity the jeans didn't pass.
So you know where I got it from.
Yeah, your dad.
Right, I think that went well.
Yeah, well, let's have the listeners vote and ask us the next topic for next week.
Okay, how do they do that?
Go to our Twitter page or our Facebook page or the webpage www.sellittoyourgranny.com, and you can find out all of our Twitter and Facebook handles. We'd love to hear from you. Propose a topic for next week. We'd be happy to share that, and if you'd like to speak on the show, we'd love to talk to you as well and get your views on big data or any interesting tech topic. And if you have a granny, we'd love to speak to her too.
Thanks, Karl.
Thank you, Neil, and thanks for listening.
Thanks for listening.